Today we're going to take this ugly BMS cell simulator that not even its mother could love, and we're going to turn it into this. It's so beautiful. Let's get started with the video. So for this design today, we're going to be using EasyEDA. I wanted to test out its capabilities. I'm really curious about its design to manufacturing capabilities. And JLC PCB was kind enough to sponsor this video after I reached out to them about this project. So we're going to be using EasyEDA's design tool. So I'm here on the website. It's just an online-based interface. So just full disclosure, I've already completed this project once, so I knew how to do it on the video, just so there's full clarity there. Some creators they act like they're doing it on the spot. No, I've already created this, and I'm going to recreate it for you in the video. Just wanted to make sure you're aware of it. That's why this project is here. But we're going to start a new project. So we're going to go to File, New Project, and we're going to call this Passive Cell Simulator. And we're going to give it a revision of number 1 and all the rest of this, and we're going to hit save. It will then generate for us a new project. And there we go. Now, when it first opens up, don't get worried about it. It was a little worrisome for me, but you have to open the stuff. It just starts out on a blank page, and then you have to open the stuff. So double click on your schematic, your page 1, and it opens here. Now, one thing I'm going to go ahead and do, and I'm going to change this to a B sheet. So we're going to change this to a B sheet. There we go. We're going to change this to a B sheet so we have plenty of room to work here. So let's start first and edit our block here. Now, you can take and change your title block, but I am lazy, so I'm not going to do that. I'm going to change this to engineer. Then we're going to change the part number to passive cell simulator number 1, and then reviewed by nobody, because we don't review things. This will be version 1, and then drawn by nobody, because we don't draw things. Okay, so let's get into placing all of our components for what we're going to need to today's build. So this is a very neat feature, I think, of this software, because you're going from design straight to manufacturing. But you go up here to select component, and then we're just going to search for these components. So the first one will be our main banana jack in. So the way I'm going to design this thing is you're going to have a power supply in, then the resistors split the voltage to go out to the BMS, and then there'll also be a pass-through for the main power. So first part number is 24.245.1. Again, I'm looking at my reference schematic over here, and that is this banana jack here. So we're going to put that here, right click to cancel that out, and then we're going to put in the 0.2, which is the black color here. So we have one red and one black. And then I'm going to go ahead and get all of my main connectors here. So the next one will be JL136HT-101601. Oh my goodness, this is a long part number, G01, which is this very large screw terminal block here, and that will be for the main output power, and we'll talk about that in a little bit. So we're going to need 2 of these, so I'm going to head and put 2 of these in here, and then we're going to need a few screw terminal blocks. So we're going to start here with DB125. You know what? This is taking too long. I'm just going to copy and paste. Because I have my reference schematic open over here, I can just copy and paste from the reference schematic. So this part number here is a 3.8 millimeter pitch terminal block, it is a 10 pin, so we're going to place this here. We're going to need one of these. And then in the same series, we are going to need a 7 pin. So let me grab the part number for it. And that is this part number here, just 7P instead of 10P. And then we're going to search, place this. And then we're going to need the 6-pin version of this same series of header. Copy that part number, go here. And you can pause the video if you want to know what the part numbers are. This design will be available on the OSH lab when I figure out how to put it on there. And we're going to need 2 of these. And so this design will be open source. It'll be available for you to download and do with it what you will once I figure out how to upload it to OSH Labs. All right, next we're going to need a 3-pin header. Now, I will warn you, this is the part number that I have, but when you search it, there are actually several parts that come up with that same part number. So when that happens, I always go to just the LCSC part number itself. So this is the LCSC part number itself, which will bring up that one stock item that we want here. So we're going to place this. We need a 3-pin header. We're going to place this. And then we need a test point. And so we'll do that. That's just short part number, so I'll just type it in. And then we need a test point. And then I believe that is all we need as far as our components go, except for a 2.2K resistor. So we're going to bring a resistor down here. This is your quick reference resistor, capacitor, inductor, and diode up here. And then for a resistor, you just select it, and then we can change the resistance here. So these are all the components that we're going to need for designing this board. Very, very simple board, but it's going to have a lot of sections in it. So let's get started. I'm going to show you how I'm going to lay out the cell sections, and then we're just going to copy and paste it. It's a beautiful way to do it. So let me just show you how we're going to stack things up. So we're going to start off here by putting these together, and then we're going to flip this around, hit Y, and we're going to hit Y. Excuse me, X. Sorry. We're going to X, and we're going to turn this around. In this part, this banana jack here, so if I pull up the product link, which is pretty, you can do everything here from the interface, use data sheet, product link, and all those things. When you look at the bottom here, these 4 pegs are not electrical. They are purely mechanical, and the one center peg is the electrical. So in this design, I'm going to take, this is your route button, I'm just going to take and route these together, and then I'm going to put a small copper port on the bottom connecting all of these together just for good mechanical strength, because we're going to be plugging and unplugging this so much. And so I'm going to take the output here. Is that correct? Also, the cursor is very helpful, so you see the crosshairs. So when I put this on here, I can see that U2 is in the center where I want it, so it looks nice. Because again, when we're designing, looks are half the battle. So we're going to connect here, and then we're going to connect here. So I am a little annoyed at how the designators turn out. Like this is U1, and this is CN1 connector 1, and this is test point 1. Now this is H1 header 1. I would rather them all be J's, but I'm not going to mess with the items right now. I'm just going to go through and design. So we're going to take this, and we're going to flip it over here. Now I'm going to make a block to reuse. I'm going to make a section to reuse. So what we're going to do is we're going to put our value there, and we're going to line it up just like this. And this will be important for later. So we're going to take and put this here. We're going to take and put this here just like this in this shape. And then we're going to bring this up to connect that there. And one thing I do want to add here. So here's the way this is going to work. Whenever you have a cell simulator, you have of course your top power, and then you go through a resistor say you have a 2 series BMS. So you would need 2 resistors. You would have your 8.4 volts here, and then you would have your ground reference here, and you would have 2 resistors. So you would have between the middle point of the resistor and here, you would have your 4.2 volts. And then between the resistor point here and ground, you would have your 4.2 volts. It's cascading. And so that's what we're going to do here, is create cascades of resistors for a 16 series BMS. However, what if we only have a 15 or a 14 series BMS? Well, that's where this header comes in. So we're going to bring power just like this in through both ends of this circuit. So through one directly through one side of the header, and then through the resistor on the other side of the header, and then this is your output. So if you had 2 cells and you needed only 1 cell, if you had 3 cells and you only needed 2 cells, then you can short this connection to this connection, and bypass this resistor, and so that way you can only put as many resistors in series as you need to. So this will be very modular. You'll be able to select how many series cells that you need. So this will be our very first reuse block here. This is the way we're going to stack this up, and then we're going to take and copy and paste this. However, I want these to be 2 different nets. I want these to be 2 different things. I want this net to be cell 16, and I want this net to be battery plus. So what I can do here is place a short. So I want to place a short flag, which is sort of like a net tie, except it does not actually have a physical footprint associated with it. It is just a virtual net tie is all it is. So we're going to place that there, and that means that these 2 are connected, but this is a different net name from this. So I'm going to go ahead and name this here. We're going to go ahead and name it, hit tab, and we're going to name it battery plus. We're going to put that there, and then we're going to connect that here. And then I'm going to put another test point here, and this will be for cell 16. So we're going to be connecting all of these cells to these headers, or to these screw terminals that will be the output going to the BMS. So this will be cell 15, this will be cell 16. Cell 16 does not get a resistor because it is the very top of the rail. So we're going to make a connection here, and we're just going to make an output here, and then we're going to connect our test point there. So let's go ahead and name our nets. This is your net label here, and so we're going to name this cell 16, and that will be here. And then unfortunately, since we're starting from cell 16, because it's easier to work from positive to negative, at least it is for me when I'm making something like this, because positive always goes on the top of the page and negative always goes on the bottom, usually, and then power flows from left to right. So this wants to amplify this up as a going up. So cell 16, 17, 18, but we're going to have to go down, and it has no mode to do that, nor would I expect it to have no mode to do that. But cell 16 and cell 15. So now we're going to take, and we're going to copy this, Control-C, and then Control-V, and we're going to place this. Oh, I accidentally grabbed cell 16. So, I wonder why cell 16 is getting highlighted. I do not know. But you can just hold down Control and then deselect it. So Control-C, Control-V, and then we're going to, I guess I'm going to place this and then delete this because I have no idea why it's doing that. And then we're going to take our connection and bring it up here, because remember that our connection to the next cell comes from the cell before it. So now cell 15, and then now this becomes cell 14. And so if you look at how the power hit is, if this was ground here, and there was a ground reference down here, so you have 2 resistors and then your top cell. So if you had cell 6, you have cell 2 plus here, this would be cell 1 plus and then ground, or cell 3 plus, cell 2 plus, cell 1 plus, and then your ground. So depending on how you have your resistors stacked up. So let's just take now this section, and this is where we're really going to be able to make a lot of progress here. I still don't know why that is highlighting, but we're going to do Control C. We're going to do Control V, and here's what I want to do to fix this. I'm going to do this, then I'm going to delete this, and then we're going to do Control C. And now we can just take and copy and paste all of these, and we're just going to go in an order, cascading all the way down. So we need 10 of these in this section, and then we're going to create another section over here that has 7. So let me go ahead and get that done, and then we'll move on to the next section. Okay, and so there are our first 10 cells routed. Again, don't forget to rename your net name. So I'm going to recheck it: 16, 15, 14, 13, 12, 11, 10, 9, 8, and 7. So don't forget to rename your net name. So now we're going to do our very first screw terminal block here. So I want to bring cells 16 through 7 into this terminal block, because that is what we'll be putting the wires in to interface with our BMS board. So we're just going to go ahead and route these, and I'm just going to route them to where they look nice. Again, looks is half the battle. So, you know, if you're a PCB designer and you have a boss, especially a boss that's not technical, oftentimes things that look good will go a long way. So like all of these nice and neat and stacked together, that obviously will go a long way towards helping you in your career if everything just looks pleasing to the eye. So I'm going to go ahead and route all of these, because if I don't want to watch it when I'm watching a PCB layout video, I'm sure you don't want to. So I'm just going to go ahead and lay out all of these. I may adjust this up and down, but I'm going to go ahead and put all these in this connector, and then we'll jump over to the next section. And there we go. Those are those 10 cells routed to this connector here. I did scoot the connector in a little bit to make it look a little better, but that's really clean. Now we're going to get to this next section. So we started here with the cell 16 positive, which would be our banana jack here, but now we need to repeat these sections, but we need to bring again a positive connection up here to cascade back down. So we're going to continue our cells. So we would take cell 7 here, and we're going to bring that up and then make that into our connection for this next row of cell connections here. So we're going to do that, and then I think, yes, still inside of our clipboard. That's what I'm looking for. It's still inside of our clipboard, is this to be copy and pasted. So we're just going to copy and paste that there. This will be cell number 6. So cell number 6, and then on down until we reach the last cell. So let me get these done quickly, and then we'll go to our last cell. So I want to explain a little bit about this very last one. I'm going to name this cell 0, and this is actually your ground reference. So I want you to think of it like this. These resistors stacked, you know, sort like this, and then like this, and then like this. So this is your main positive, this is your main negative. So this is connected to here, right? This is connected to here, and then it goes through this resistor to here to create cell 1 reference, and then through this resistor here to create the reference for cell 2, and then the top of this resistor would be the reference to cell number 3. Well, that's what we have here. So we have through this resistor, which goes up and creates cell reference number 1, and then through this resistor that goes up and creates the reference for cell number 2, and then through this resistor which goes up and creates the reference for cell number 3, all the way up to cell number 15 here. Through this resistor creates the reference to cell number 16. So that is why there is a cell 00 here. That is your main ground point for your battery cell stack. And a lot of BMSs have a separate negative cell input, or a separate cell negative sense input away from the main battery minus of the rest of the pack. So that is why that is there. Just a quick explanation of how that is. So let's go ahead and get these connected to our header. So again, the same as it was before. I'm going to shorten this. This is pointless right here. This just needs to be, and then Yeah, just like that. That just needs to be just like that. That didn't need to have that whole thing on there. But just as we did before, we're going to take and line that up very nicely and just bring our connections in here evenly spaced apart. So let me jump cut this, and then we'll come back to do our thermistors. So that is that section routed very nicely to that header. I almost forgot I can't do our thermistors yet because I have to do the main negative first. I almost forgot about that. So we're going to take our other connector here, and I'm just going to place it right about here, and then I'm going to make another short connection here to separate cell 0 again from, and delete that one, again separate cell 0 from the main power path. Again, there is no physical footprint associated with this like it would with a normal net tie, but it does separate it in the hierarchy of things. And I'm going to bring it over here from C1. I'm going to line that up the same as it is over here. So I'm going to bring this over here, hit X to flip it over. This is our main negative coming from, again, that banana jack that's going to come from our power supply. So we're just going to bring this connection over, and this, and then like this, and I think I'm going to bring this down, yeah, so it looks a lot better. So that is our cell simulator completely wired up. So we have our separate power paths, because these are, I'm going to design these to carry about 10 amps. So we have a complete separate power path from our sense path, which is what you want. Even when you're designing BMSs, that's what you want. So let's get started here on the thermistor simulator section. So one thing I'm going to do first is I'm going to take these part numbers. I'm just going to do like this because they're getting in my way. So we're going to hit X here. Oh, that is annoying. It's okay. We can fix it later. And one thing I already found out by doing the preliminary layout or the before layout on this is that these need to be opposite of each other for the nets to line up properly, where the outputs of the screw terminals have got to go. So they do need to be in this 6 through 1 and then 1 through 6 here. They need to be opposite of each other. Oh, that reminds me, these need to be changed. So what I'm going to do is I'm just going to Control X, cut, and then paste back and hit Y to flip this over. There we go. And then I'm going to move that, and then this needs to be flipped over as well. So Control X and then Control V, hit Y to flip it over. Almost forgot about that. Those do need to be flipped over for the PCB layout's sake, for everything to be correct. So we're going to do sort of the same thing here in the thermistors. So the thermistors will come in here and go out here, but I'm going to put 10K parallel jumpers here for if you're trying to simulate just a normal 10K NTC, which most BMSs use. And then if you wanted to actually use an external thermistor, you can if you want to. It's an either or. So we're going to use the same header that we're using now, and we're going to paste those in here. We're going to do this, and then we need a 10K resistor here. Already by default it's 10K, so we need a 10K resistor in here. We don't need 2, we just need 1. And so we're going to go ahead and route that here. And then this will be our main positive here. So I'm going to go ahead and route this over. And this will make more sense in a second. I'm going to go ahead and route this over. And then the top of our header will connect here. And then I'm going to route what will then be our negative connection here. And then I'm going to route this here. So the way this section is going to work is this is your thermistor positive and negative, even though there's differential. But your thermistor positive and negative. So imagine this is your thermistor positive and it's going straight through your pass-through, and your thermistor negative. So this is, your differential pair here for your thermistor. And so if you don't want to use an external thermistor, you can put a header jumper here to short your to short across your pair here, your thermistor plus and your thermistor minus. But if you do not want to use this resistor and you want to use the output, then you can put it here between 2 and 3, which is just shorting this 10K resistor back to itself connected to the thermistor minus here. So you can use the external thermistor. So pretty neat, just a simple thing, but you can either parallel this 10K if you want to, or if you're doing like I do with a decade box to where I'm testing the trip resistances of the thermal input and all of those things, then you can do that. So I'm going to take, again, repeat this circuit 3 times and then finish up this section of the schematic. So there we go. The thermistor section is routed. Looks good. It looks the way I expected it to, because again, I'm looking at a reference design. So I'm just going to go ahead and rename all of these nets here to their proper names, thermistor 1 plus, thermistor 1 minus, and all of those things. And then we'll get to finishing up this schematic and then to our layout. All right, there are all the nets for the thermistors. So thermistor 1 plus, 1 minus, 2 plus, 2 minus, 3 plus, and 3 minus here going straight out to the connector. So a few more little things to do here to finish up the schematic. We're going to put here a battery ground, and so we're going to do place ground, and I'm going to use an earth ground symbol to make gatekeepers mad. So we're going to call this battery ground here. And then I believe that is it. I believe that is it for let me check my reference schematic over here. Again, I'm not too good to admit to you I'm using a reference schematic. Yep, that looks perfectly good. I believe that is beautiful. That is what I wanted it to be. So that's the schematic finish. So let's get to doing the PCB layout. Well, I'm going to take a water break first, and then we're going to do the PCB layout. Okay, so let's get into our PCB. So we're going to save this. Then we're going to go to Design, Up Convert Schematic to PCB. Then it's going to ask you if you want to import everything. Of course we do. Apply changes. And there we go. It sticks everything in here that we need. So one of the first things I'm going to do is I'm going to take and put all the components up here, because that is the way it is in every other design tool that I've ever used. The origin is here. I don't know why I wanted the origin to be here. It wants the origin to be here. Now, I will go ahead and show you this. If you do not put a board outline in here, it just assumes one for you. So if we hit 3D and let it load, you see that it has just a preliminary board outline put in here. We are going to put in a board outline, but just letting you know it does that. So that's the first thing we're going to do, is we're going to do the mechanical stuff, and then we'll get to the layout stuff. So one of the first things that we're going to do is we're going to change to millimeters to make sure that we're working in millimeters, and then we're going to do our board outline. So we're going to select our board outline layer, a rectangle, and I've already changed my grid to 1 millimeter. You can leave your grid to whatever you want it to be. But we're going to do 160 by 160. Well, I'm just going to type it in. 160 by 93. Or 93 by 160, excuse me. 93 inches wide, 93 millimeters wide, and 160 millimeters wide. That is what... or 160 millimeters high. That is what it ended up being for my design before. So there we go. There's that. And then we're going to adjust our origin here to be right there. So that is our new board outline. And then we're going to change that layer type here to board outline. Oh, excuse me. It's here. Type. And we're going to change it to board outline. And so now if we go to our 3D, there we go. Now that we go to our 3D. So let's get our main connectors set here. So we're going to start here with our B- terminal, which is this connector number 2 down here. And we want it to be 27.5 and 18. That's where we want that one to lie. And then well, it has gotten away from me, but if you need to get back, you can go to View and Zoom All Window. I am still a little bit unfamiliar with this CAD package, so please bear with me. This is the very first design I've ever done, and then I just finished up this design yesterday or the day before, so I'm still very unfamiliar with this CAD package. But I am very thankful for reference design. And then the center of this is at 28, or it needs to be, well, you know what? I'm going to change the other one. And then this needs to be 117 millimeters. And then we need to change the center of this one to 28 millimeters, just like that. And then for our main output connectors, we need to change this to 76 millimeters. We also need to rotate it. So this needs to be 76 millimeters. Also, if you're looking at the footprint, you do see the arrow. The arrow is the way the wire comes in. So that is very nice. The silkscreen is very nice for that. And then center Y needs to be 98. And that is, make sure that is for BAT plus. And then for BAT minus, the same thing. Over here on my reference design, the center again is 76. We need to rotate it. 76, and then the center Y is 18 millimeters. Then to our headers, so CN3 here will be rotated, and then center 86 and 72. This one, again, make sure you rotate it to where the wires are coming in the proper way. So the wires will come in this way. So it goes down here somewhere. The center 86 and then 30. Oh, I put that one in the right place. I put it right in the right place. I'm very proud of that. I don't get to do things like that very often. I need to win. I'm going to go ahead and switch back to the top layer because looking at it is annoying. And then for our thermistor headers, CN4, and then the wires are coming in the back side for that, so you need to make sure you put that in the right place. Will be 5 millimeters and 139 millimeters, and then CN5 will be A6 and 130. So there are our main connections done. The reason I keep closing out the 3D is for some reason the 3D doesn't update correctly all the time. I'm not sure why. But this is what's really cool about this package. So everything is already ready to go. All your 3D footprints, everything. That is what's really cool about this CAD package. So everything's already ready to go. All of this has been verified, and then we can order this as it looks. So next comes the hard part, which is getting all of these cell connections together and getting them nested. So I'm going to show you what I created to make this a whole lot simpler. So these are stacked in here the way they are in the schematic. So this is the way they were in the schematic. So here's cell 16 all the way, and then back up, and then down through cell 0 here. So everything is connected the way it was in the schematic, and then here are your thermistor ones. But we're going to make this into a nice layout that can be replicated. So you can do a reuse block and replicate the layout. So we're going to do that. We're going to change our grid here to off click. We're going to change our grid size here to 250. So we can have a little bit more control. I know some people's going to yell at me, you can't do that because it's going to throw everything off. It's not going to throw everything off because the reference of this, the middle pin of this 3-pin header is on that 1 millimeter grid, and I'll show you why that's important here in a minute. So we're going to take and put R16 here, and we're just going to put R16 somewhere right in there. It's a happy little R16. In case you've seen the Joy of Assembly video, of course, it's a happy little R16. But we're going to, again, these cursors are really great, but we're going to line this up right here. And then we're going to take and put a text box right here. So this will be cell cell 0, and we're going to put this text box here, and then of course we're going to change our layer to the top silk screen, and then I'm going to change some properties about it. I want my stroke through it to be 0.3, and I want my height to be 2.5, and then we're going to bring this in just like this, and then we're going to Control C, Control V, and this is going to be short, and then I'm going to change the text height of this. This is going to be a 0.2 stroke, and then 1.8 height here, and we're going to put that there. Control C, Control V, and we're going to do, this will be on, and we're going to change the reference. So right now it's left bottom, and we're going to go right middle. So the reference here, they'll line up better with these pins here. And this also needs to be right middle. Almost forgot about that. That needs to be right middle so it'll line up good with the center of that. And there we go. Is that lined up? Good enough. And there we go. So this is what our reuse blocks are going to look like. So what's going to happen is you're going to have cell 0 here, and you can either choose to short it or to put it on, which will connect it through the resistor. So let's go ahead and make those connections now. We're going to go here and just bring that down and bring this straight across. And then we're going to switch to our bottom layer right here, and we're going to do this, go across, hit tab, and change this to 1 millimeter, and then we're going to simply right click. And there we go. This will be our reuse block. So let's draw a box around it. So we're just going to draw a box very quickly around it. And then 18. There we go. And this will be a on the top silk screen, and then this will be a line. Confirm. And just need to adjust it out. You have to grab the points, adjust it out just a little bit. And there we go. We have a block. And what we're going to do is we're going to take each one of our component sections, and we're going to copy them and paste them just like this, and we're going to create blocks we can stack together. So let me show you how this is going to work. So we have this, and we're going to create a group. So group selected, we're going to call this cell 0. And so now this is cell 1 here. So we're going to select this, right click, group, reuse layout, and we want to make sure we zoom in, so it needs to be highlighted. So when you go in here and you like select the middle of this, you see it's not highlighted. For some reason it doesn't. You can zoom in and highlight it, but you want to select the center of that when it's highlighted, because again that's on that 1 millimeter grid. And then we're going to take and we're going to place this. If you look at our blue line here, our cursor line, we're going to place this line to line here in the middle, just like this. And so that's staggered together. This is our cell number 2. So I want you to notice here, if you look at our group, this group is now cell 1. It will go up. It'll cascade upwards and keep creating a group. So we're going to select this. We're going to do group, reuse layout, go here to our cell number 1, select group. It will copy and paste that, and then look at our cursors, make sure you line all that up. Bam. And now this is cell 2. And then we can keep going all the way to our cell 16. So that's what I'm going to do here, is cascade all of these up until our cell 16 and create a block here. Also, do not forget to rename your cells as you go, because it can be quite annoying. You may have to adjust them a little bit. So you'll have to ungroup this and then regroup it. You may have to adjust it a little bit. But it can be quite annoying once you get all the way up the tree and have to rename your cells. Trust me. I've been there and done that. So I'm just going to go through all of these and recreate these for all 16 of the cells, and then we'll get on with the rest of the layout. Okay, and that is all cells 1 through 15 done. Now, something I am going to do here is I'm going to copy this, and then I'm going to paste it for cell 16. And I'm just going to delete everything else out. We're going to delete this out. There's not any objects that go with this. We know that. It's just a repeat. So we're going to do that. Delete the copper out. Delete that. Delete this. Change this to cell 16. And then move this here. Oh. Move this here. And then this. Just like that. And then that becomes cell number 16 there. So there is our cell block right here. This is cells 1, cell or ground, but cells 1 through 16. So we can take and short or put in place any of the cells we need to in order to simulate whatever we need for whatever BMS we are working on. So that is our complete cell stack right here. And so what I'm going to do is I'm going to select them all and then grab them by the center of this one here. I'm going to grab them by the center and I'm going to place them about right there. Glitching out a little bit. On the other design, make sure if you're grabbing these, you grab by the center of these. And now I did change my grid back to 1 millimeter. I forgot to mention that. But I did just eyeball this kind of in the center. I'm going to back it up a little bit. I'm going to put a label here. All right, so with those in place, I'm going to change my grid back to 250. So that way this is lined up here. I'm going to create a box off of this corner. And then I'm going to make this box off of this corner. I'm going to make this box about probably 6 millimeters should be good enough, right? Yeah, 6 millimeters. And we're going to do this as a line of the top silkscreen layer like we did before. And then I'm going to put a text box in here that says Cell Simulator. Just like this, and then I'm going to change it to the top silkscreen. I think stroke width needs to be 0.5, and I'll change this to 4 millimeters tall. And we're going to put that just as a label in here. So that's the cell simulator. I can tighten that up just a little bit. And then we'll take and tighten this up just a little bit. So again, remember, looks are half the battle. So there's that. There's our cell simulator. And so that section is completely routed. Now let's get to the thermistor section. I say completely routed. It was not completely routed. It's completely finished, I guess, as far as placement goes. So I have changed my grid again. I need to change my grid again, make sure it is 250. Yep, make sure my grid is 250 here. Okay, and so for the thermistors, it's going to be the same exact routine here. So we're going to do the same exact routine. I'm going to copy some assets here, and then I want to paste them up here, and then this will be thermistor number 3, because what I want is this will be thermistor number 1. Thermistor number 1. There we go. Because what I want is when I'm using the terminal block, I want this section to be thermistor 1, thermistor 2, and thermistor 3. So thermistor 1 will be on the bottom, and this will not be short. This will be off. So this will be off, and then this will be on. And so we're going to take, like we did before, and we're going to draw just a box around this. So I don't understand why it doesn't save your what you did last. So I drew a box last, and I wanted the box to be the same as I drew last, and it's not the same as I drew last, and it's okay. I mean, it's a free package. I'm not going to complain, but it's just a little bit of a pet peeve, I guess you could say, for it not doing what quite what I want it to do. And there we go. That will be our block for our thermistor. So again, I'm going to group these together, and this will be thermistor number 1. And then I'll come over here to the other thermistors. Again, right click, group, reuse layout. We'll go to this one, select the center of this, and then there is our thermistor number 2. So I don't know if you notice this. You notice how it's going kind of wonky right here. Sometimes it does that, and whenever that happens, I just click it off, and then I'll grab it and then bring it back. For some reason, sometimes it does that. I still haven't figured out why it does that, but it's okay. So do you see how this thermistor 2 is messed up? So what you can do is go to group, and you're going to remove from group. And now you can adjust this, but how do you join the group back? Well, you can go here, group, join group, and then since we named our groups properly, thermistor 2 will be this group. There you go. And now thermistor 2 has joined that group again. So the last thermistor, right-click, group, reuse layout. There we go. Reuse layout. We're going to go here, and then there we go. And then again, it's doing that thing. I'm not quite sure why it's doing that, so I'm just going to click off and then go back. Bam. There we go. And then this will be thermistor number 3. And there is our thermistors laid out. So let's take this section, get it where we want it, just kind of in the middle. All it's got to be is sort of in the middle. And have I? Yes, I have. So you see I've made this mistake here. I have changed these two thermistors where they should be. So this should be here, and this should be here. So I can take and just switch those very quickly, and then change this to 3. And then not move that, and then change it. That's the beautiful thing about these groupings. You can move anything around that you need to. So change that to 3, change that to 2, and voila, there we go. Everything's hunky-dory. One thing I do want to do is change this grid again back to 1 millimeter, and then make sure that all these are sitting properly on the 1 millimeter grid, which they are. So grid size, I'm going to leave it at 1 millimeter. And then I guess it's time to start doing our layout. So let's actually start laying some copper down for all of these connections. So I'm going ahead and change my grid size. I'm going to change it down to 0.5 millimeter. And if you notice here, there is no cell 16 net. There is no cell 16 net because this is not a physical item. This is just a virtual net tie. So it separates this on the schematic, but we come to the PCB, it is all the same net. So just be aware of that, but we're going to take and we're going to start routing this trace. So as you can see here, the trace is not the proper length. So we're going to right click, we're going to hit Shift W, and then we're going to change that to 1 millimeter because I want this to be 1 millimeter. Now I'm routing here on the top layer, and I should not be. I should be routing on the bottom layer because the top layer will have a large copper pore across it to connect to here. So we're just going to be routing on the bottom layer here. We're going to come across and then down straight into our battery plus connection. And then we'll also tap into that for our again, Shift W. We'll tap into that for our test point connection as well. Now the reason I am using 1mm traces is, if I don't want to use these big connections and I just want to use these smaller connections, and I still want to be able to pull 1, 2, maybe 3 amps through it, which is what these headers can handle, just a little bit of load testing small BMSs, I want the traces to be able to handle that. So the 1mm traces are more than enough to be able to handle that. So we're going to start routing our main cell connections here. So they're just going to come across, and then they're just going to go down, and they're going to go straight in to here. So 14, and they're going to go straight into here. And cell 13, and they're going to go straight into here. And we're going to go all the way down until we reach the negative connection. So I'm going to go ahead and route all these, and then check back in after I'm finished. So I thought I'd show you this here on the bottom layer here. So I routed these two nets to cell 14 and then to cell 15. Watch this. Select this net, control, select this net, control C, and then control V, bam, and then control V, bam. So I can go all the way down and connect all of these nets together with the same traces that I connected those first two to. So copy and pasting is amazing. If you don't copy and paste in your designs, I don't know what you're doing. Like you just don't know what you're missing out on if you do not copy and paste in your design. So that is all of the cell routing. So here's how the top turned out. I'm quite happy with that. And then of course here's how the bottom turned out, and that looks pretty cool as well. So let's do the last few little things here. So we're going to do our battery ground. Again, Shift plus W. Sometimes it doesn't want to. So, I hit Shift plus W. It already said it was 1mm when it wasn't 1mm. Sometimes it doesn't do quite like I would like it to do. It's a free software package. I'm not going to complain, of course. But sometimes it is a little funky, but it's okay. It's free. While I'm down here, I want to go ahead and place a copper region. And we're going to just place it right around our battery ground here, and then our net name will be what is our net name? 1N435. 1N4354 is what our net name is. 1N4354, and then we want to fill style, and then we want to do, yeah, I believe that's right. Confirm, and then it pours around all of these. So what I'm going to do is I'm going to select all of these pads, come over here, custom, pad connection is direct. And then our polygon copper region, we're going to rebuild selected, and there we go. And that just is provide mechanical strength. So that is on the bottom side where they solder on, and that is just to provide mechanical strength to support those pads, and that is all that is for. Now I'm going to Control C, copy that. Then we're going to go up here, Control V, and do that. And then our net for this will be 1N978, and then we're going to select again all of these and change them to direct connection, and then rebuild the selected copper core. And there we go. That is everything for the cell sections except for our main copper pores. So let's do our main copper pores. So we're going to go here to, this is the copper region tool, the one with the dots, and we're going to do polygon. And so we're just going to come right here. We're going to go like this, and then we're going to go over and figure out what will look nice. And then we're just going to, looks is half the battle. I always say that, looks is half the battle. So, you want to impress if you can. So looks is half the battle. Working, sure, you want it to be functional, but if it's functional and it looks like a little kid drew it, then it's not going to be as good as if it is a beautiful or just a good looking layout. So this will be battery plus, confirm, and we need to make sure, of course, that we select this and this and this and change it to direct connection. Now, it is my plan, it is my goal to get 10 amps out of this, to make it do 10 amps. That is my goal. Now, whether it actually will, I think it will. But that is my goal, to make it do 10 amps. So there's our main battery plus connection, and then we'll do our main battery minus connection here. Same thing. Just straight over instead of having to bend it, and this will be, battery ground. That's right, confirm. Got it a little bit short. And then we'll do this and this and this. Custom direct connection, and then we'll select our copper port here, and we'll just go ahead and hit rebuild all. And there we go. I'm going to expand that out a little bit right here. We're going to give it a little bit more. There we go. And then we're going to copper region, rebuild selected. There we go. And that is our cell section routed here, except for battery plus. I did forget about that net, didn't I? Battery plus. So let's go ahead and route that. And we're just going to route that on the bottom side because I forgot about it. If you see, there's no real room for it. And I don't want to mess up the layout as it is. Again, do you see this? For some reason, it doesn't want to change, and I'm not exactly sure why, but it's okay. It's okay. So there we go. There's that one little lonely trace on the bottom because I forgot about it, but it's fine. It is fine. The layout still looks good. It's perfectly fine. So now on to our thermistor connections. Same thing. They do not have to be 1 millimeter, but for the sake of it looking correct, I'm going to go with 1 millimeter. So what in the world? I don't understand. This is a tidbit annoying because it just does not want to. See that? It just does not want to stay at 1 millimeter. And I'm not sure if it's because I'm doing something wrong or not, but it just does not want to stay at 1 millimeter. You know what? Let me check in on that and see if I'm doing something wrong. Well, I found nothing that was going to be any help. So I guess I'm just winging it at this point. But this is this, I have to admit, this is annoying. So there is that. And then when I go to start a new one, it just does not help at all. But it's okay. It's okay. So let me finish routing this, and then we'll finish up our build. Okay, so that is the nets routed for this. So I made them look like pairs together, so it looked everything looked kind of intentional. So we're just going to route the last of this. I'm going to change my grid to 250 to route the last of this. So we're going to go up, and then we're going to go over, and then we're going to go over to thermistor 1, and then this goes there. And then we're going to hit control, copy, and we're just going to paste this copper. Again, if you're not copy and pasting, you are wasting time. If you were just not copying and pasting, copying and pasting is amazing. And there we go. It looks like everything is laid out properly. The last thing I think we need to do is put in some mounting holes. So we're going to put in some pad holes here. I'm going to again change my grid back to 1 millimeter, so that way I can just eyeball line it up in the corner. Diameter 2.5 for a 2.5 millimeter screw, or you know what, 3. We'll go ahead and do 3 millimeters, so that way we could do a 3 millimeter. Oh, that was the wrong thing. So that way we could do a 3 millimeter or a 2.5 millimeter screw, and then Make sure we take out the designator for the pad, and it has no net. No net. Yes, no net. And then we're just going to line it up. Again, since it's a 1mm grid and it's an even board, we can just line it up to where it's properly the distance away from the corner, just eyeballing it. And then there we go for a M2.5 or an M3 screw, depending on what kind of mounts that you have. And then we'll just line that up there, and then line that up there, because again, in the corners, it's easy when you have everything on the same grid. So, or mathed to the same grid. So there we go. It looks like that this is a completed board. Let's look at the 3D here. Yep. Yeah, I'm happy with that. It looks like everything is oriented properly. Yeah, I am happy with that. So let's see here. Did I forget about anything? Let me look at my reference design. Oh, there is one thing that I forgot to do, and that is put in the label for up here. So this will be thermistor, and then that goes here, and then we're going to draw a box around it, or yeah, we're going to draw, we'll just lines is what we'll draw around it. So let me change the grid to, let me change the grid to 250. There we go. And then we'll just go to our top screen layer. We're going to draw some lines. Line, hit tab. There we go. We're going to draw a line out, line, and then line. And then we're going to change this. I believe this needs to be a little shorter, and then there we go. That is great. Right there. Nope. It's great right there. Down a little bit. All right, and there we go. I believe that we are finished with this design, and it is beautiful. I have to admit, it is beautiful. So just a few little last minute touches that I'm going to put in, and I'm going to copy these from the other design because I am lazy. Of course, you can label it however you want. Here's how I'm going to choose to label it. So there are thermistors, and then again for the other side, here are our thermistors. Our thermistor labels here, and then and it jumps sometimes too. It just jumps on me for some reason. I'm not quite sure why. Just a few little things that are just a little bit annoying, but you know, it's a free CAD package. I'm not unhappy with it. I'm not unhappy with it at all. Now, if I had paid for it, I might be a little bit unhappy, but I didn't pay for it. Copy, and then paste. So there are all of our cell labels, our battery designator labels, and then all of our thermistor labels. So let's take one final save, one final look at the 3D. And look at that. Isn't that awesome? Isn't that so cool? That is awesome. So our board is completed. Now I want to order it. So feel free to leave the video, but I'm going to try to order this board. So I'm going to go here to order, and I want to order the PCB, I believe is what I need to do. Order PCB. Yes, run a design rule check first. I forgot to run a design rule check. Oh, cool. So confirm, and it's going to open up JLC PCB here. I assume, yes, it is. And so let's see what it does. Okay, there's the PCB. So what do I need to do? PCB assembly. Okay. And then next. Okay. Next. And will it preload in all of my build? Yep, it preloads in all of my builder terminals. What is this thing? Comment this part just make. Please confirm. Oh, okay, so it threw out an error here that it does not match, but it is 2.21K. And then it says that that's 10K and 2.21, and then this does not match. This is a test point, and it does not match. So let me hit search here. Yes, and then this is the correct part. So we're going to hit select there. So we confirmed that there. Do we need to confirm the rest of them? No, it doesn't give me a select option here. It just did for that one part. Okay. So I checked those 3 parts. It did throw caution errors, which is nice. So that way you know what you are or are not ordering. So let me hit next here. And then component placements. And there we go. It has loaded. This is neat. So I can zoom in, and it gives me all of the designators and then all of the parts. Then I can hit 3D and then do an actual 3D check. That is awesome. Look at this. Look at this. That is very neat. I have to admit, I'm very impressed. This is very neat. And so you can just confirm everything yourself. And if I hit next, it gives me pricing here. PCBA price. Manual assembly fee. There's going to be a manual assembly fee and all of that stuff. So not terrible. Not terrible. Not great, but not terrible for 5 prototype boards. $70, $77 is not terrible for 5 rapid prototype boards. Of course, I could assemble them cheaper, myself, but for the convenience of just having them made, or for the convenience of this exercise. Of course, JLC PCB sponsored this video, so they'll be making these PCBs for me. But if I had to get rapid prototypes done, it might be convenient at this point in my career. At this point, this will be a development board. At this point in my career, it's kind of like I would rather not waste the time and buy it. But you can make that decision yourself. But I believe this will be the end of the video. I'll probably, put this in the card and get all the logistics worked out of ordering it. But I hope you did enjoy today's video. If you enjoyed it, please make sure you like the video, you share it, you subscribe to the channel. I think this thing is going to be neat. It's going to be very useful for me as a BMS designer for testing things. I am curious whether you would buy one or not. Of course, I'm going to release this on OshLab as soon as I figure out how to do it. I'm going to release it. You'll be able to download it yourself if you want to. But if I had them available, would you buy one? Like I said, at this point in my career, even if it's something I can make, if I can buy it off the shelf, I'm going to buy it off the shelf so I can use my time doing something else. So if you made it to the end of the video, that is my question for you. Leave it down in the comments. If I was to order, 100 of these, actual production of these boards, would you buy one? Would you want one for your development? I don't know. Let me know. But please like, share, subscribe, and comment. And I will see everyone in the next video.